Welcome to this webinar organized by EMS. Today we're going to speak about how to deal with the solenoid design in EMS. As you know, EMS is electromagnetic simulation software that is fully embedded inside Solidworks. This webinar will last about an hour. 40 to 45 minutes will be a presentation that's going to be done by Bill, the application engineer, and the last 15 minutes, 20 to 15 minutes, will be answering questions. We'll answer questions as we go, and actually, gentlemen, please, when you have questions, type them in the chat box, and Bill will answer them one by one once he's done with the presentation. Welcome everybody, and now I'm going to make Bill the presenter to go over a solenoid design in EMS.
Okay, thank you, Adam. Good afternoon, everybody. So here I have a solenoid example that I've prepared for you for the presentation of today. As one of the main advantages that we have here at with EMS is that we're fully embedded inside Solidworks. So everything happens within the Solidworks environment. No importing, no exporting, no geometry healing, none of those problems. So we thought it would be interesting to bring the electromagnetic solution inside the Solidworks environment. So here, as you can see, you have the Solidworks tab where you usually do your CAD the regular way. Nothing has changed. Same thing. I'm going to just cut my solenoid in half just to show you the inside of it. So the brown piece is the coil surrounded around the plunger, the blue piece, and then the transparent is the stator. We take full advantage of all the features of SolidWorks, and so one of the things is we can define a motion inside SolidWorks motion. EMS is going to be able to actually automatically couple to that and analyze the motion for you. Okay, now once we've done with the SolidWorks side, and we did every aspect of that. The other step would be to go inside EMS and actually do the electromagnetic analysis. So the first step is to create a study or a design scenario. When doing so, we have 5 solvers that come with a basic license: the magnetostatic, the electrostatic, the electric conduction, the AC magnetic, and the transient magnetic. Depending on what kind of application you're interested in, you would decide which one of these you're going for. Basically, the magnetostatic covers the magnetic field generated by DC current or permanent magnets. Electrostatic covers the electric fields and the voltages generated by DC current. Electric conduction covers the conductivity of certain structures of your structure. So AC magnetic, if you're exciting your coils with an AC current. And lastly, the transient magnetic basically covers any other kind of current, whether it's a pulse, step function. You can even import current versus time curves, and so basically the transient magnetic goes over a certain time span, breaks it into, samples it into pieces, and then at each time step it's acquiring the value of the current at that time step. So you can allow any random variations of current. Also, we have two optional modules that are the steady state thermal analysis to study the joule heating, and also the motion analysis. So basically, as I mentioned earlier, any motion you put inside SolidWorks motion, any motion analysis you put inside SolidWorks motion, EMS is going to be able to analyze it and analyze it for you automatically. Okay, now once we've created the study, here for those of you who are familiar with SolidWorks simulation, you'll notice that EMS Manager tree is very similar to that of SolidWorks simulation. And that is one of the reasons why EMS is a gold certified product by SolidWorks. So it looks and feels just like SolidWorks products. Solids is where you define the material for each component, so you can actually specify any material. We have very rich library here with most of the commonly used materials. EMS also allows you to create your own material library where you can create and edit material. Okay, so here in this case, it's copper here for the coil, for instance. You notice the blue check mark there. It's saying the material is ready. You can also do, let's say here, if I'm doing plunger and it's ferromagnetic, you can just copy paste by drag drop feature. So it's very simple, very easy, very handy. If you're interested in the thermal analysis, you would set up the convection in here. And basically the convection is done on the outside air, which is included in every electromagnetic simulation. You have to have an air box enclosing everything because we want to capture the fields that are propagating in the air surrounding the structure, which is a significant portion of the total field. So it's important that we model the air around the structure. Okay, right, and then also the coils. So basically you have two options here. You can set up a wound coil or a solid coil. In the case of solenoids, it's mostly going to be wound coils. And this is an advantage we have. If you're dealing with a wound coil, you do not need to go inside SolidWorks and draw all the, I don't know, 50, 60, 70 turns of coil. All you need to do is do the overall envelope, come over here, specify the AWG or the diameter, specify the component, the coil, the entry port, the exit port, the number of turns, let's say 50 turns or whatever, and then the current per turn. Forces and torques, this is where you get to specify the where EMS basically will compute the force density distribution all over the structure at each mesh node. But if you wanted to sum up, if you want to sum up the force on a certain part, then you need to specify it here. So let's say in this case we're interested in the force on the plunger. The force on the plunger, so basically yeah, you can specify that and the solver will automatically add up the forces on that plunger. Obviously if you're dealing with a force on a coil, then it's a Lorentz force, not a virtual work. But in this case it's not a coil, so we have a virtual work. The last step in the pre-processing is the mesh. And meshing, this is where we really stand out compared to competition, because we have here what we call the mesh control option. Basically, the mesh control option is a way of giving you full control over the mesh. That way you can have accurate and fast simulations at the same time. So, and this is a very interesting feature that sets us apart from the competition. Now, once you mesh it, this is how the meshed structure is going to look like, as you can see here. Okay, so now after meshing, all you need to do is right click and hit run. After running, EMS will generate these result folders for you. Okay, now I'm just going to go over them. So you got the results table here. Basically, the results table covers all the lumped quantities. So you got the force, the torque, the back EMF, resistance, inductance, flux linkage, and energy. You notice here, because we're associating with motion, we have several time steps, and so you'll see the force. The force is mainly going to be in the y direction, so you see the force value varying at each time step. Okay, so at each time step you have a different force value. You can actually plot that as a function of time, so you can see the variation of force over time. You have a cursor here that you can use to trace to follow the trace and figure out the values there. You have it in a chart that you can save as an Excel or a TXT file for any further processing. Same thing could be done with the back EMF. Okay, so you can plot the back EMF too. Again, you can use that same cursor. You have a chart here you can save as an Excel or a TXT file. I mean, same thing could be done with the energy. Okay, so you can see the amount of energy there as your plunger moves, and the plunger is actually being moved by the coil. We did not apply any force to any mechanical force to it, so it's just the coil that is generating the EMF that's pulling it inside the solenoid. Okay. Again, you can always use the chart there. Now, also, what you can do is you can do the magnetic flux density. You can plot that in a 3D or a 2D format. So here, for instance, in a 3D, you can choose which time step, because remember, we're coupling to motion. So at each time step, we have a new plot. So you can choose which time step you want to plot. And you can choose if you want to see, let's say you want to see the vector lines, you choose vectors. And so this is the magnetic flux density lines there. So you can see they're going in circles there. You can animate, so you'll be able to see as the force is being exerted on the plunger and as it's being pulled into the structure, how is that changing your magnetic flux density. Okay, and again, this motion could be actually saved to a media file that you can later use in a presentation or put on a website. So you have that flexibility. Okay. Also, you have in here, you can do probing. Well, probing basically allows you to click on any position in your structure. EMS will display the value for you at that position. Now all the probe points we clicked at are stacked right here in the chart with the X, Y, Z coordinates and the amplitude at that coordinate point and the node number. So they're all saved. You can plot them. You can save them also as an Excel or a TXT file. You can also do listing. Basically, listing is going to bring you every single node in the structure with the XYZ coordinate of that node and then the value at that node. So you have all the nodes right there. So every point in your structure is out there. Okay. You can also do, instead of a vector line, let's say you want to see scalar plot and you want to look inside, you can do a fringe plot. So here with a fringe plot, you can actually, again, you can do the other manipulation. You can play with the chart option where you can change the scale, because sometimes in certain areas, the areas where with big magnetic flux density values tend to shadow what's happening in areas with small values. So you can manually play around with the scaling. So you can change the scaling to any scale you want, or you can just stick to show min max. Okay. You can do section clipping. Basically, you cut through the structure and look at what's happening inside your structure. And this is one of the features that I personally find very interesting, because a lot of times I want to look inside and see what's happening in my structure and how it's varying from inside. And EMS actually gives me the flexibility to do that. And the cut plane, you can position it anywhere you want, as you can drag it with a mouse the way I'm doing right now. Or if you have a particular coordinate in mind, you can type that in here. You can also change the angle. So let's see if I want to rotate this around the x-axis. So you can actually cut at an angle, so it doesn't have to be a 90-degree cut. You can also tilt around the y-axis. Okay. You can do an inside out to decide which side of the plane you want to plot. Okay. You can do plot on section only, and it's going to plot only on the cut plane. It's like a 2D plot there, like a, okay. So you can see just what's happening on the cut plane there. You can do more than one section. You can superimpose up to 6 sections. Okay. Also, you can also do an ISO clipping plot. Basically, ISO clipping is going to bring all the spots in your structure that have the same value. You can specify that value using this cursor right here. So all the spots that have, for instance here, all the spots that have 0.0211 are right there in my plot. This is very handy when you're looking for minimums and maximums. Again, you can superimpose up to 6 ISO clipping surfaces there, so there's no limit in that regard. Again, I'm just going to go back to, I'm going to cut it into 2, and then you can actually also animate and see what's happening inside as your plunger moves. So you can actually see the variations inside your structure. Again, you can always save this motion to a video file that you can put on a presentation or on a website or share with colleagues. Okay. Also, you have the probe feature, I mean, just like the vector plot, so you can click anywhere and probing will basically display the value for you at that position. Again, you have them all in a chart here that you can save as an Excel or a TXT file. You can still do also, you can also decide if you want to do just the, instead of the resultant, let's say you're interested in the field just in the Y direction. So you can actually do the field in the Y direction there and make that plot. Okay, so you can see the variation there. And again, now, if in this case, if you do a listing, it will bring you the magnitude of the field in the Y direction only. So this is a lot of clients would like to have this, so they orient their field in the Y or Z, whatever direction, and then they can acquire the listing from that. Okay, so then comes the other feature is the 2D plot. You know, sometimes you want to see, for instance, you want to have some numeric values. So what you can do is you can do a 2D plot. EMS will ask you to specify 2 points, any 2 points in your structure. There is no limit there. So let's say, for instance, I pick this point and that point. I mean, just any 2 random points. EMS will go along the straight line connecting those 2 points, breaks that line into this number of samples that I specify right here, and then it's going to draw the magnetic flux density for me along the straight line connecting those 2 points. Again, I can always use my cursor to read the value there. You have it in a chart that you can save as an Excel or a TXT file. You can also do something else. For instance, let's say I want to see what's happening at this contour right here. Let's say the contour of the coil right there. So what I can do is I can insert reference geometry points, Solidworks, and okay. So here I can keep increasing the number of points that I want. So you can see the purple points there. You can put in as many points as you need. For instance, here I did 100 points. So it did add all those points for me here. So now what I can do is I can come over here, do a 2D plot, and I can just ask it to import. And as you can see, EMS actually is importing every single point in that structure. Okay. And then when I say yes, EMS actually plots for me the magnetic flux density along the contour of that coil right there. so you can actually see the variations. Again, you have a cursor that you can use, and we have it in a chart here that you can save as an Excel or a TXT file for any further processing. Okay. Alright. And this is not limited to, let's say, this contour or contour on the structure. I can actually do a contour anywhere in my structure. For instance, here I'm going to take this one. I'm going to insert a reference plane parallel to that plane. Okay. So I'm going to just flip direction. So for instance, let's say I want to see at this point, at this level right there. So at the level of that plane, I define that plane, and then I use it as my sketching plane. I introduce a sketch. So let's say I want to, like here, at this contour right there. So you can notice where my contour is. Okay, and I want to see my magnetic flux density along that contour, just as an example. Okay, so what I'm going to do is I'm just going to go ahead to simplify things. I'm going to delete those points I created earlier. Okay, and now I'm going to create new points. As a matter of fact, by the way, I can keep those points, but just for simplicity, so that I don't create confusion, I remove them. So I want to create these points on this contour and 100 points in there. So now EMS is actually creating those for me. Okay. Sorry, the Solidworks that's actually creating the points. EMS now is going to just acquire those points and use them to do a 2D plot. Again, I can import them. I can manually select any points I want to select as well. That's another option we have. But if there are 100 points, it's easier to just import them. And then say yes. Okay. Now, as you can see, you can actually see the magnetic flux density along that contour. So again, I can use my cursor to read the values anywhere. I have them in a chart here that I can save as Excel or a TXT file. Okay. Okay, now the same thing, for instance, let's say, okay, another feature is I want to compute the magnetic flux density through this surface right there. So what I can do is I can say compute flux, select that surface, and then I say compute. So now I have my magnetic flux on that surface. Okay. If I want to see the force density, for instance, I can see that through here. Okay, so you notice now the force density distribution. I can do a section clipping, cut through that. Obviously, certain areas have much higher density than others, so they're being shadowed. So what I can do is I can manage change the scaling. Okay. So you can play with that as well. Now let's say I've done all of this. I made the changes that I needed to make. I made the analysis, and now I want to start the what if scenarios. Okay. Now what if scenarios, they happen on two levels. The first level is you want to just keep the geometry the way it is, but you want to play, let's say, with the current, the material property, any of those parameters there. What you can do is you can take this study. You don't have to go through the process again. You can drag this study, drop it here, and then give it a name. Let's say, for instance, study 3. Now, you notice here EMS has copy-pasted everything for me from the other study. The material property, the load restraint, the coil, the force, the mesh, the results, everything. Now all I need to do here is I go to the areas and the parameters that I want to change, and I can change that. For instance, let's say instead of using mild steel, let's say I want to use iron. Okay, so I can change that. I change just the parameter I want to change. Then I can right click here and hit run. It will only run this study for me. So all the results for the other studies will be kept untouched. And so I get to save the results of those studies and just play with the with this one. Or what I can also do is I can stack several studies in a row, and then right click here and hit run all studies. So if I have several scenarios that I want to test, I can stack them all and then hit run at the end of the day before I go home, and when I come back in the morning they'll be there for me. And so what you can do later on, what you can do here is I have these two studies, for instance. So I copy paste this. Okay. Now what I can do is I can do a 2D plot, specify any 2 points right here, 200 samples, and then what I can do is I can say ask it to compare results. And then I have a list of all the studies that I've defined, and I can compare results with those. Okay. Now, in this particular example, because it was not, as you can see, they're being superimposed on top of each other. Let me make it more clear there. Okay. Yeah, because here I didn't change anything, so they're sitting right on top of each other. But if there was any variation, you would actually be able to see that in here. And you have it in a chart here with both graphs. You can save that as Excel or a TXT file for any further processing. The other approach in the analysis is the multi configuration. I'm just going to bring up quickly another example here to show you how the multi configuration works. Just bear with me for a second here. Okay, this is another example of another solenoid type where I do what if scenarios, but this time it's with the shape of the structure as opposed to just changing the current or the material property or whatever. So here we play with several configurations. So we define them inside Solidworks. So we play with the gap here and with the height of this blue piece there. So if you can see this configuration and then that, and as you can see we played here with the gap between these two and then the height of this piece. Okay. So what I do here, again, it's the same approach. So as I do my study here, let's say I did it for the default configuration, I've run it. It has all the parameters and all the plots and everything. Now I want to see the what if scenarios, so I can drag and drop, call it config 2. Then you notice here it's asking me SolidWorks configuration to use, and here I would have a list of all the configurations that I've defined. So for instance, let's say I pick the one I called 425, say yes, and now here EMS actually copy pasted everything for me, the material, the plots, everything, and it associated it with this. Now all I need to do is just right click and run this. I can have several of them and run them all together. So here for instance I've already done that, and then again let's say I want to do the magnetic flux density. I want to go from this point here to that point there. Okay. Okay, yeah, sorry. And then I can, again, as I mentioned earlier, I can compare results. So I set up the this one and that one because I have 3 configurations there. And now you can actually see in one graph the variation and the effect of my what-if scenarios on the magnetic flux density. Okay, so basically here all the figures there, I can use cursors to read the values at each one of them, so you can see the cursors here. Can, for instance, just leave this. I can use all of them. You have the values right there on the cursor, so you can keep reading all the values. Okay, and I have a list right there, so I can actually have them all in Excel or a TXT file for any further processing. Again, I can do a 3D plot of that. Okay, can do a section clipping there. And yeah, by the way, one more thing is I can change the orientation of the cut plane, so it doesn't have to be in that particular plane there. So I can do along any plane. And then at the end, after I've generated all these figures, all these plots, all these results, actually EMS is capable of generating a report for me. So instead of me having to go in and copy paste every plot so I can show it to managers or to colleagues and clients, EMS actually does that for us through the reports feature. So you decide which section you want to include, which section you want to leave out. You can do the company logo, you can upload that, put the date, the author name, the company, choose the format. HTML or Microsoft Word. And when you hit OK, EMS actually copy pastes every plot for me into a Word report. The advantage of this is it's a Word report, so it doesn't have to be anyone can view it. They do not need to have Solidworks or EMS license in order for them to view this. So anyone can view it. You can see here the meshed model, all the pre-analysis setup right there. Okay. The figures, all the figures that we've generated are right there. And you notice here, for instance, it preserves any orientation that you put the figure at. So if you can choose how to orient each and every figure individually, and you can take advantage of that feature too. Notice here all the plots that we have been copy pasted, material property and everything. So it's pretty flexible in that regard, and it's again our mission is to make electromagnetic design as easy as possible. And so we keep adding these features, and we keep trying to make it as easy and as intuitive as possible. And with this, I would come to the conclusion of my presentation, and I'll be more than happy to take any questions if you have any. If you have any questions, please feel free to type them in the chat box. Question is, what do you do when a configuration change causes the mesh to fail? To be honest with you, I've never had that issue before. I mean, I've helped a lot of clients with that, and I haven't had that issue, because if you can manage to get the original one to mesh, because basically mesh will fail because there is a disproportion between certain parts, like very huge big parts and a very small parts, and that disproportion kind of creates an imbalance. But if you can manage to actually mesh the original configuration, then you don't have that issue anymore. And so all the other configurations, they usually tend to mesh. Now, in the case of, in the event if that happens, you have the option again of going into that configuration. For instance, if you can see for me here in my model, I have the mesh of each configuration. So what I can do is I can activate, let's say, this one, and I can go in here manually and tweak the parameters of this mesh and to make it mesh. But to be honest with you, I've been dealing with this software for a while. That never happened. I mean, if the original one meshes, the rest mesh. Okay. Another question is what kind of SolidWorks license you need to use EMS. Now, a regular license would do, but if you're interested in motion, and you want to do motion instead of doing multi configurations, for instance, sometimes you want to do motion, then you need to have a premium SolidWorks. Otherwise, any SolidWorks version would do. Another question is why would the plunger exceed the center of the solenoid? Again, it depends on the structure. It depends on how you set up your solenoid. Certain ones would stop at the center. Certain ones would keep going. So it depends on the design. Here, I just wanted to examine the force at all positions. So I analyze it like that. Okay, so do we have any other question? Another question is, do you have a limit to the number of studies you can run? No, there is no limit. If you have a good computer, you can run as many studies as you need to. So there is no limit right there. So you can keep piling up studies and just running them all together at the same time. So you're not really limited there. And again, the computer depends on, again, what computer you're using. So the more RAM you have, the easier, the faster, the faster the simulation is going to go. And then you'll be able to pile up, as many studies as you need to. We recommend with EMS, we recommend a minimum of 6 gigs of RAM for a computer that's going to run EMS. Yeah, if you have that, you don't have much to worry about. Obviously, the more RAM, the better. Another question is, do you have a wide customer base that uses EMS for solenoid applications? Yes, actually we have a lot of customers from all over the world. They use EMS for a lot of different applications, but we have a big community of solenoid designers that actually do use EMS for solenoids, and their results are very accurate. We get a lot of testimonials because we deal with our customers on a regular basis and we communicate with them. We help them and we provide support and we stand by their side. And as I communicate with them, we constantly keep getting feedback on how they're getting flow results and how accurate the simulation is to what they've actually measured in the lab. So it's a very accurate, very precise software. Okay, so do we have any other questions?
Well, seems like there is no more question. So thank you, Bill, for your presentation. I hope, all the attendees are able to get a better idea or a deeper idea about how a solenoid is easily done by EMS, especially with the integration inside Solidworks, and how we can take advantage of that integration the best way possible. Because as we all know, the more you keep your geometry, safeguard your original geometry, the better the results are. That being said, for any sales questions, please address your questions to Adam at emworks.com. Adam at emworks.com. For any technical questions, please send them to Bill at emworks.com. And this video or this webinar is recorded and it will be available from Monday. On Monday it will be available on our website www.emworks.com, and there the webinar section, and the video will be there. Also, I would recommend visiting the events, webinar and exhibition section on our website. There's a lot you can see there. You see the shows we'll be attending or we attend, the webinars recorded, the events, the upcoming events and all that. So please always refer to our website www.emworks.com for all kind of info, and to either Adam at EMWorks for sales questions and Bill for technical questions. Thank you all. I hope you enjoyed it again, and you all have a great end of the day. Bye-bye now.